Hi, welcome back. Today we're going to talk about one of the most important concepts in Calc 1, or if you're in high school, Calc AB. So where does the power rule exactly come from? Because you're sort of just given it. Simplify derivatives, great. Where does this actually come from? So this is going to be the power rule derivation. So very important stuff. So let's start off with the definition. Basically your definition of a derivative. So if you think about, if you have a graph, let's draw the graph right here. Woo! So essentially, like before, you would be given 2 points, and you find the line between the two using the m is equal to y2 minus y1 over x2 minus x1, right? So essentially what we're going to do here is shrink the space in between the two enough so that it's basically a tangent line. So let's make this definition. So the definition that we're going to use is actually quite simple. It's going to be the limit as x approaches p of f of x minus f of p over x minus p. Okay? Great. So now we can continue with the derivation. So, given a function f of x is equal to x to the n, find the derivative. So we're going to do this. All right, so let's start off with our definition. And I'm actually going to switch to blue pen for this, so it stands out a bit from the words. So we have the limit as x approaches p of f of x minus f of p divided by x minus p. Great. So now we're going to use our function and substitute. So this is equal to the limit as x approaches p. F of x is x to the n. F of p, just plug in the p, is p to the n over x minus p. Now, wouldn't you just say, hey, we can just plug in p right away? Well, there's a reason why we can't make the denominator 0. So we're trying to get rid of that right now. So we can use the binomial theorem to factor out an x minus p on top. And then on top, we're left with this fun stuff. X to the n minus 1 plus p to the times x to the n minus 2 plus dot 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 p to the n minus 2 times x plus p to the n minus 1. And that's all over x minus p. Those cancel. Woohoo! Okay. That's equal to the limit as x approaches p of x to the n minus 1 plus p x to the n minus 2 plus dot 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 p to the n minus 2 times x plus p to the n minus 1. We're almost there. Yay! Okay. So now we can actually directly substitute in the p because we don't have any problems. So this is equal to p to the n minus 1 plus p to the n minus 1 plus dot 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 plus p to the n minus 1 plus p to the n minus 1. Okay, so that's quite interesting. Now, how many terms do we have here? Let's investigate up above to help this out. So you could think of this here as being a p to the 0 power, right? Because anything to the 0 power is 1. P to the 0 is 1. This goes all the way up to the p to the n minus 1. So that means there are n terms here. Okay? So then that equals np to the n minus 1. So from this, we concluded, therefore, I'm actually going to switch this back to black, f prime of p, the derivative notation, is equal to np to the n minus 1. We'll even put a little box at the end to signify that the proof is done. But pretty simple. I hope you enjoyed, learned a little something, and have a great day.